All right, let's talk about EmbeddingGemma. It's the small AI that thinks big, and we're about to dive into why this new model is making such huge waves. And it's for a really surprising reason. It's incredibly small. This is the story of how we're finally getting big AI thinking right in the palm of our hands. So let's start with a really basic question. Why can't the world's best AI just run on your phone? I mean, this question really gets to the heart of a major challenge in AI today. We have these unbelievably powerful models, but they're so massive they have to live up in the cloud. So what's actually holding us back from putting all that power right into our pockets? Well, it all boils down to this fundamental trade-off, something we can call the AI size problem. See, on one hand, you've got your cloud-based AI. These things are powerful, they're huge, but they can be slow, and you always need an internet connection. Then on the other side, you've got on-device AI. And yeah, it's fast, it's private, it works offline, but let's be honest, it just doesn't have the same horsepower. For years, you had to pick one, power or size.
But what if you didn't have to choose anymore? This is where our story really kicks off.
This is a new family of models from Google, and the two words you really got to remember here are lightweight and open. It's designed from the ground up to be both really small and totally accessible to everyone.
And here's the absolute kicker. The whole point of EmbeddingGemma is to completely break that trade-off we were just talking about. The goal is simple. Give you all the power of a giant cloud model, but in a tiny package that can actually live right on your device.
So just how small are we talking? Around 308 million parameters. Now, you can think of parameters as, well, they're like the individual knobs and dials an AI uses to think. And in a world where we're used to hearing about models with billions or even trillions of these dials, 308 million is tiny. It's definitely small enough for on-device applications. But that leads to the million-dollar question, right? How powerful can it possibly be?
Well, the secret is in the recipe. See, the researchers didn't just take a big model and try to shrink it down. No, they came up with a whole new recipe for power, a way to cook up a small model that performs like a big one.
Okay, but before we get into the recipe, we need to understand one quick thing: text embeddings. The best way to picture this is to think of a super smart librarian. This librarian takes any piece of text, a word, a sentence, whatever, and converts it into a set of numbers, a vector. It's like giving every idea its own unique address on a giant virtual bookshelf, where similar ideas get placed right next to each other. This is how AI really gets the meaning behind our words.
Okay, so here it is, the secret sauce, this four-step recipe for a small, powerful AI. It starts with Step 1, smart initialization. Then you've got Step 2, knowledge distillation. After that, Step 3 is spread out regularization. And they finish it all off with this amazing final step called model souping.
Let's look inside that recipe for a second. That knowledge distillation part, it's basically like EmbeddingGemma has a master teacher, in this case, the much bigger Gemini model. So it's not just learning the right answers, it's learning how the master thinks. Then it's encouraged to use its entire brain, so to speak, to make its representations more expressive. And that model souping thing is just wild. They basically train a bunch of slightly different specialist models, and then they combine them, average them out to create one single super expert. It's genius.
So they followed this really clever recipe, but did it actually work? Well, the results are, frankly, pretty surprising.
All right, so how good is it, really? This is the moment of truth. How does this little model stack up against the other contenders in its weight class? Models under 500 million parameters.
Okay, check this out. For multilingual tasks, look at that chart. You can see all the other models kind of clustered down at the bottom. And then way up at the top, all by itself, you see that red star. That's EmbeddingGemma. It's not just a little bit better, it is in a completely different league.
And what about code tasks? It's the exact same story. All the competition is bunched together, and then there's EmbeddingGemma, just way out in front. It's another clean sweep. And finally, for English tasks, the pattern is just undeniable at this point. For the third time in a row, it is the undisputed champion in its size class. It just completely dominated. This quote from the actual research paper just says it all. EmbeddingGemma's performance is so strong, it is comparable to models nearly double its size. Think about that. It's not just the best small model. It's so good it's punching way above its weight class, competing with models that are almost twice as big. That is a wild leap in efficiency.
Okay, so we know it's powerful for its size, but for on-device apps, sometimes you need to shrink it even more to get maximum speed.
This is a process called quantization, and usually it really hurts performance. So, what happens when you try to shrink EmbeddingGemma even more?
This is the amazing part. Look at how little the performance actually changes. If you look at the mean score on this multilingual benchmark, at full size, BF16, it scores a 61.15. When you shrink it down to int 8, it only drops to 6093. And even when you shrink it down to its smallest, fastest size, int 4, it's still at 60.62. The drop is tiny, almost nothing.
The translation here is super simple. It stays strong even when you compress it. You can squeeze this thing down to make it faster and more efficient, and it stays incredibly powerful. It's just really, really robust.
So, this is all leading to a big question. What does this all mean? We've got this small, powerful, robust AI. What does that actually unlock for the future? What's the big deal for you and me?
Because this isn't just about a cool research paper. This is about what this technology means for you. This opens the door to real-world stuff that just wasn't practical before. Imagine smarter, totally private search on your phone, or getting instant translations that work offline. Think about AI assistants that are actually responsive because they don't have to call home to the cloud every single time. This means new kinds of apps that understand you better than ever before. The potential is just huge.
And really, that brings us to the final thought here. For so long, the best AI has been this distant thing, something we had to access through the cloud. What EmbeddingGemma shows us is that that's all changing. So the real question isn't just, what will the big tech companies build with this? No, the question is for all of us. When our best, most powerful tools can finally fit right in our pocket, what are we going to build next?